Okay, this is where we stopped. We had these answers here. We've gone through canceling units, and then you're going to go ahead and try your hand at a couple. And so we've got the 272 centimeter tall man, 8'11". There's the picture. Quite a tall fellow. So at 8'11", being the tallest person in the world, 272 centimeters. How many meters would that be? So we've got our conversions, that a meter is the same as 100 centimeters, and a kilometer is the same as 1,000 meters. And so we got to go from centimeters to meters. So we don't really need the second one. We just really need the first one. So if we do 272 starting unit, centimeters, so number unit, and then we get rid of centimeters, they go to the bottom, and we put meters on top. Well, centimeters are going to cancel, and then I've got meters, which is what I want, so it'd be 272 divided by 100. And so we're going to go ahead and do that in our calculator, and we're going to get 2.72 meters. And so I divide by 100 because it's on the bottom. Why is it on the bottom? Because I need to get rid of the centimeters. I used this first conversion because it was the one that got me where I wanted to go. I didn't need to use the second one. I only needed one. Now, the second one said that he only lived 22 years. A lot of times when people are bigger, it's a larger strain on their organs and things like that. And so a lot of times people that are particularly tall or large, a lot of times they don't live as long. It's just it happens that sometimes that things are a little too hard on their organs. And it's probably what happened here. He had some sort of human growth hormone item that was probably just going crazy to get to 8'11". But anyway, we got to go from 22 years and we got to get to minutes. So we can only use these conversion factors, right? We're not looking this up on the internet because I don't really care about the answer, I care about the process. So we're going to start with that 22 years. All right, so 22 years, and then I'm going to get rid of years. So 1 year is 365 days, so years at the bottom, so they'll cancel. Then going to get rid of the days. 1 day, 24 hours, so I'll go ahead and cancel days, and I'll go to hours, and then I'll go ahead and cancel those days out. I need to now get rid of hours. 1 hour, 60 minutes, so we'll go ahead and put minutes on top, hours on bottom. So see the pattern, right? The pattern is always unit I start with goes away. Unit I start with goes away. And so whatever unit's on top is just constantly being canceled until at the end we can go ahead and do the math. And so we haven't done, with significant figures, which are not, don't have to be used all the time, but if we are using sig figs, this would be 480,000. Without significant figures, your calculator answer 483,240. How do you do it? 22 times 365, enter, times 24, enter, times 60, enter. And I'm kind of skipping the bottom unit because it's a 1 and it's not going to mathematically do anything. So, all right, hopefully you did great on those. Let's look at a more complicated problem, which is what the heck do I do if there's a unit in the numerator and the denominator? What do I do with these derived units? So if you look, it says I've got a car. It's going 35 miles an hour. How many kilometers per second would that be? Well, if you have a unit on top and a unit on bottom, you just write it out as normal. And then you either cancel the units on, excuse me, you either cancel the units on top or the units on bottom, but you can't cancel them both at once. So just pick, either I'm going to work with miles or I'm going to work with the hours, and then it's the same process. So if I'm going to start with miles, I'm going to put miles at the bottom and convert them into whatever I can convert them into. So I can convert them into kilometers. So miles cancel as normal on the bottom, not anything strange. So that gives us kilometers, which is part of what they wanted. They wanted kilometers per second. So cancel your miles. You're going to keep those kilometers, so we're going to leave those alone. Now we got to get rid of hours. Well, hours are on the bottom, which this is weird. We now need them on the top to cancel. So we need them on the top of this conversion factor. So I'm going to put hours on top. So to cancel hours, hours on top of the second conversion factor. And then I can turn them into minutes. So 1 hour, 60 minutes. We know that. But look, now your hours cancel. See top, bottom? It's just that instead of the top being first, this is bottom and top, which is the same thing. We have something that will cancel. We go ahead and get rid of our minutes. Notice minutes is on top, right? So like we're getting rid of minutes. It's on bottom and it's on top of the third conversion factor. Away they go. And see, now I have seconds on the bottom, which is what I want. And so that is a good thing. Okay, in your calculator, this is a little tricky. 35 times 1.609, because that's on top, we hit enter. We divide by 60, we hit enter. We divide by 60 again, we hit enter. And there we go. It's the equivalent of 0.156 kilometers per second. So again, what do we want to see? We want to see units canceling. We want to see the thought process. We don't really care a lot about the answer. We care about the process. All right, let's slide down here to our next problem. And look, this is a student problem. This is for you, your chance to shine. And so we have the hot dog eating competition. So Jimmy Chestnut holds the record, and that record is 73 hot dogs, which does include buns, and that's a lot of hot dogs. So he ate that many hot dogs and that many buns in under 10 minutes. So for our problem, we're going to say that the rate that he ate all these hot dogs, I don't think I've eaten 73 hot dogs in my entire lifetime, but anyway, the rate at which he would eat the hot dogs would be 7.3 hot dogs per minute. Let's convert this to pounds per second. So I want you to try this. Pause the video. Try to do the derived units, the process of converting as we go across. So getting rid of units on top or units on bottom, etc. So pause the video and come back and see how you did. All right. Hopefully you started with 7.3 hot dogs over 1 minute. So hot dogs per minute. Get rid of them hot dogs. What can we turn those hot dogs into? Well, we can turn them into ounces. So hot dogs on bottom, ounces on top. See, I got rid of my hot dogs. I'm going to go to my ounces, right? Okay, let's get rid of ounces. What can we turn those into? I can turn them into pounds, which is conveniently what they want. So ounces on the bottom, pounds on top. See, I'm getting rid of those ounces. So remember, top to bottom, top again to bottom. Now I have pounds. This is what I want. I can keep that. I got to get rid of those minutes, turn them into seconds. So minutes are now going to need to be on top. 1 minute on top, 60 seconds on bottom. So see, now your minutes have canceled. Now you can do the math, all right? And my unit is actually incorrect there. That should say 0.027 pounds per second. I'm not sure why it says grams. So let's go ahead and fix that. Okay, so I cleaned that up. That was a slight mistake. So here we go. Just a little unit mistake. But there we go. 0.027 pounds per second. And like I said, I want the correct units, so I probably need the correct units in the slide there. So that's just a little error on my part. So, but anyway, the number is the same. All of the work is correct, and hopefully you were able to sort that out. So in chemistry, we don't really do a ton of these more complicated ones, but it is good to be able to do the derived units. But what you want to take away from these notes is this, and I tell my second year students this. I tell students getting ready for their exams on more complicated units that, hey, if you in physics or in chemistry, if you're doing a math problem and you can get rid of a unit and turn it into what you want, then you stand a much better chance of success. And so whatever unit you have, be able to get rid of it by putting it usually on the bottom of the conversion factor, and starting from that spot will usually put you on the path to getting the problem correct. So I'm going to pause the video here. We are going to have some practice over this, and you're going to get a chance to shine, to show us all the chemistry that you know.